Moving into our second session for the evening, introducing Asynchronous SQL Alchemy. Let me introduce our speaker for this session, Sebastiaan Zeeff. Sebastiaan is a software engineer for the Ordinary Pythonians and a fellow of the Python Software Foundation. As a Python enthusiast, he loves discussing the inner workings of the language and coaching others to become better developers. In 2021, Sebastiaan gave talks at various conferences, including PyCon, Python, PyCon Indonesia, Pyjamas, and Pygron. He is also active in the Python community as an owner of Python Discord, an open source contributor, and as a Python educator. Sebastiaan will now address you all based on the topic for this session, and you can also direct your questions through the Q&A segment so that Sebastiaan can answer all your questions just after the session. So make sure you direct your questions to the Q&A segment. So I would direct them to Sebastiaan. And without further ado, let me introduce our guest speaker. And Sebastiaan, the platform is all yours to conduct the session.
Hello, thank you very much. I'm very happy to be here. I hope you are all having a very wonderful PyCon Sri Lanka so far. I'm going to start sharing my screen so you can see my slides. You should be able to see them now. So today I will be talking about SQL Alchemy, and not any kind of SQL Alchemy, but mostly about asynchronous SQL Alchemy. So what you see here is a painting. It's a painting called The Alchemist, which I thought was very relevant. And what you can see here is an alchemist in his workshop, and he's doing a lot of things at once. So if he's human, just like me, he probably only he can probably only focus on one thing at a time, but he's not exactly doing one thing at a time. He has multiple tasks that he's doing next to each other, but all the while focusing on a very single task of its own. And this is basically the same as with Asynchronous SQL Alchemy, or SQL Alchemy, if you prefer that pronunciation. We're going to focus on one task, but in the background, we may do some input and output concurrently. So I prepared a question for you before we start, and it might be good to share that poll with you. And I just want to know how many of you actually used SQL Alchemy before. So if you like to vote, then we can see the votes. I see a lot of no's, a little more no's, a few yeses in there. So this gives me an idea of your background and how I should approach SQL Alchemy or SQL Alchemy. And I'll immediately address one of the questions at the top asked by Sumudu Herath. I hope I pronounced your name well. And that is, what is SQL Alchemy or SQL Alchemy good for? And I think that's a really important thing to address before we get into the talk. SQL Alchemy or SQL Alchemy is a database toolkit for Python. So basically, you can use it to talk to a relational database, like a MySQL database or a Microsoft SQL Server or PostgreSQL. And you can use SQL Alchemy to talk to that database from within Python. And I'm going to go into that a little bit deeper later in the talk, but that's the main purpose of SQL Alchemy. And I will address the ORM question a little bit later. And I will also talk a little bit about the which databases support it. So, right, close the poll. I think that should work now. Cool. Well, let's get into it. So what am I going to do? First, I'm going to talk a little bit about SQL Alchemy itself. I'm going to explain what SQL Alchemy is and what you can use it for. Then I'm going to talk about the difference between synchronous and asynchronous input-output. You may have heard of asyncio, which is all the hype in Python these days. There are a lot of asynchronous frameworks like FastAPI out there. And I'm going to talk a little bit about the difference between the two to really understand what SQL Alchemy adds and what you need to keep in mind while using SQL Alchemy in an asynchronous application. Then I'm going to compare synchronous versus asynchronous SQL Alchemy. So the synchronous SQL Alchemy is, if you've used SQL Alchemy before, the SQL Alchemy that you're already used to. Most of SQL Alchemy is synchronous, but now they've got an asynchronous extension. And I'm going to compare the two in the usage, so you really know what to focus on. And then lastly, I'm going to go into a few of the caveats of using asynchronous SQL Alchemy. You will have to do a few things differently because of the asynchronous workflow, but we'll get to that later. It all has to do with implicit input and output. So before we dive into the talk itself, who am I? Well, I'm already introduced a lot, so I'm not going to give you a big introduction again. My name is Sebastiaan. I live in Europe, in the Netherlands. So it's morning for me. I think it's afternoon for you. And I hope you're having a really nice day. I work for Ordina, as said. I'm one of the codesmiths and Python software engineers. And codesmiths just means that I get to give courses, trainings, or talk at conferences. And my employer supports me in that. Python Discord was also already mentioned. I'm one of the owners. It's a large online Python community. And finally, and something that wasn't mentioned before, I'm also a volunteer of EuroPython, which is a large Python conference in Europe. The last two editions were fully online. The next edition will probably be hybrid, so part in person, but part online as well. So if you like another conference, definitely check out the hybrid or online options. Right. So let's dive into the talk itself. So SQL Alchemy. Well, SQL Alchemy is a database toolkit for Python, and this means that it allows you to write Python code, but still communicate with your database. So it provides a layer of abstraction of communicating with your database without you actually having to write raw SQL. You still can for some purposes, but you can also write Python code. And it consists of two parts. It's the SQL Alchemy core and the SQL Alchemy ORM, or Object Relational Mapper. But the core itself is already a very full tool. You can basically use the core standalone in your application. You don't have to use the ORM because the core of SQL Alchemy is what takes care of all the heavy lifting. It allows you to connect to a database, make transactions. It allows you to define your schemas. So what kind of tables do you want in your database? What kind of columns? It allows you to define that. It even allows you to create your schemas in the database, although I would recommend using a migration tool for that, like Alembic. And finally, and this is really the power of SQL Alchemy, it has a very powerful SQL expression language. And what this means is that you don't have to write raw SQL, but you have a Python expression language that is close to SQL, but not quite, that allows you to create a database. And it's a sort of abstraction over the actual SQL that SQL Alchemy will generate for you. And this also means that you can write your application once, and if you migrate to a different database backend, so say you go from MySQL to Postgres, you don't have to rewrite all your queries because databases have their own kind of dialect. They differ slightly in their SQL language. By using this SQL expression language, you write your queries in Python. You can use it to communicate with the database, and SQL Alchemy will actually take care of translating those queries into the actual SQL queries that you need. And that's really powerful. And what I like about SQL Alchemy is that it's not opinionated. So it's non-opinionated. And this means that it gives you the full power of SQL without telling you how to do things. So you can use the design you want, the design patterns you want. You can design your application and your architecture in any way you like. SQL Alchemy will not tell you how to do things. And then I think that's a really great feature of such a toolkit. Well, and then the second part, and this is probably the most famous part, and this is the SQL Alchemy ORM, or Object Relational Mapper. And this is a really great tool to work with your data in a way that we understand instead of the database. So if you think of your database, it's full of tables and data and rows. And if you query the database, you get just a row or multiple rows of results back. And those are strings, integers, other values. But there's no inherent meaning connected to those values. You know what they are. You know that you queried the user table, but the data itself, it's just values. You have to know what you're doing. So what does the ORM do? It allows you to define high-level or abstract Python classes, like a user class, that you understand. Now you really have a user with meaningful attributes like a username, an email address, and everything that you can think of that's important for a user. And then you can map that Python class, that meaningful, insightful Python class for you, to tables in the database. And this means that you can now store your user in a database. You can synchronize your neat Python object to the database. But also, if you have information in the database, you can now synchronize it with Python. And instead of raw values, you get a very neat Python object that you can understand and you can work with. So ORM really allows you to work with your data in a higher level, more abstract way that's actually insightful, and it really allows you to model your domain in terms that you understand. They're no longer raw values. And finally, it also allows you to define your queries in terms of those models. So you can say, I want the user whose username is equal to this specific string, instead of having to translate it into a more abstract, well, there's a table and I want this value in this column to be equal, then return all the values in that row that matches the query. No, you can really talk about the user, and you want the user whose username is equal to something. So you really get an abstract way of thinking about your database. So that's the ORM part of SQL Alchemy. There are actually a lot of ways in which you can use this. And if you're really interested in things like domain-driven design and separating your domain layer from your database layer, so architecture, I really recommend this book. So if you're intrigued by that statement that I gave and you really want to know more about it, go get this book. It's a great book. It's one of my favorite Python books, certainly my favorite Python book that has been released in the past couple of years. And it really goes into architecture patterns, and it will even use SQL Alchemy in its examples. It's not a SQL Alchemy book, but it will use it in its examples of how you can then build an awesome architecture. Anyway, let's go back to SQL Alchemy. So when you have SQL Alchemy, everything you do in there is synchronous, which means that you have regular functions. The interpreter will just do one instruction at a time. It's an entirely synchronous framework. But over the past couple of years, asynchronous Python, asyncio, has become really popular. You have frameworks like FastAPI, you have various asynchronous frameworks to make web requests, to interact with, say, Slack or Discord. There are really a lot of asynchronous frameworks out there, so people wanted a asynchronous ORM or database toolkit. And this gave the maintainers of SQL Alchemy a little bit of a problem, because you have this entirely beautiful framework of SQL Alchemy. It's really powerful, but it's entirely synchronous. So do we now have to create an entirely new version of SQL Alchemy, just one that happened to be asynchronous, which would obviously mean that everyone will have to relearn SQL Alchemy, and the maintainers will have to maintain two truly separate versions. In fact, they didn't have to. And this is because of the beautiful design of asyncio, of SQL Alchemy, but also because of the nature of asyncio. They only had to redesign the part that actually communicates with the database. And to see why that is, I have to explain the difference between synchronous and asynchronous Python a little bit. So that's what I'm going to do next. I'm going to briefly focus on the difference between synchronous and asynchronous input and output. And this is really important. When you talk about async IO, the IO stands for input and output. So it has to do with communicating with something that's outside of your application. And you're going to do that in an asynchronous way. Well, to understand that, I'm first going to look at synchronous input-output. The normal default Python that you use is synchronous. And I'm going to have a very simple application, a single-threaded application, single process. And this means that we really only have a single thread of execution, like you see here. So you might think of your application in terms of classes, functions, modules, packages, all those neat separations and neat boxes that you can think about. For the interpreter, basically what it does on a lower level, it executes a single thread of instructions. And that is what single-threaded means. And this quite literally means that if it executes an instruction, like the first one here, it executes it, it waits for it to finish, and then, and only then, will it move on to the next instruction. And then it will execute that one, will wait for it to finish, and move on to the next instruction, and so forth and so on. And this typically makes a lot of sense, but there is a moment when this might not be the most efficient solution, and that is when we're going to do input and output. So notice this little red line here. This is a line that does input and output, and in the context of SQL Alchemy or SQL Alchemy, that is communicating with a database. So this line, what it will do, it will have a SQL query, and it will send it to the database, and then we'll have to wait for the database to reply. This instruction will only finish when we get the response of the database back. And until that time, our application just pauses. It will wait. It will not do anything else, because remember, this is a really simple single-threaded application. So we wait, and then we get the response back. And only when we get the response back can we move on to the next instruction. Now, I've made it sound really bad, but in a lot of applications, it doesn't really matter. But if you do a lot of those input and output statements, you might want to think about doing it in a slightly different way, in a way that allows you to do more of those at once. And this is what asynchronous input and output does. And just to be clear from the start, in an asyncio Python application, you're still only using a single thread and a single process. So there's no magical concurrency going on. But what we do is we visualize the application in a slightly different way. So at the bottom of your application, there's an event loop. And your event loop will take care of running various tasks, things that you need to do. And there's always only one current task with instructions, just like before. But you might have other tasks that are scheduled. They're paused. They're just waiting to be executed. They're not doing anything at this moment. But the event loop will, when they get their turn, execute them. Well, within your current task, you will still only execute one instruction at a time. So in this case, you will execute the first one, wait, move on to the next one, execute it, wait, and so on and so forth, until you get to one that does input and output. And what's going to happen here is that we're going to initiate the input-output. So in this case, Python will send off the query to the database. But instead of simply waiting here, pausing, not doing anything else, we're going to pause this entire task. We're going to put it back into the event loop. We're going to schedule it for later to pick it up when we do have the response. And in the meantime, we will start doing a different task. So this is what asynchronous input and output is all about. When you're doing input and output, when you're communicating with something outside of your application, over the boundaries of your application, instead of waiting for that input-output to finish, we're going to pause that task and we're going to do another task in the meantime. So our application doesn't just wait there. So we minimize the waiting time that our application does by doing something else in the meantime. And if you think about it, that's what we mostly do as well. If I'm going to make a cup of coffee, I'm not going to wait there until the coffee maker is done. I'm going to do something else in the meantime. Maybe check my phone, check my messages, maybe make breakfast or whatever. But I'm not just going to wait for that one task to finish. I'm going to pause it. Something else will take care of it, and I can do something else in the meantime. So now let's get back to our SQL Alchemy app. And this is now an asynchronous SQL Alchemy app. And I've added a little event loop to the bottom of the Python logo there. So this is our SQL or SQL Alchemy app. It's asynchronous. But as I just said, it truly only affects the input and the output of SQL Alchemy. So if you have the input-output layer here, that's the only layer that truly needs to be changed to an async workflow. And this makes sense because your database, it doesn't really care that your application is asynchronous. It will still expect the exact same queries. It will understand the same SQL. It will send you back the same response. So the database, it doesn't care that your application is asynchronous. And this also means that the rest of your application, the one that generates the queries or that actually works with the results, that mostly stays the same as well, because the queries will remain the same. How you handle the results will remain the same. The only thing that will really change is how you send those queries to the database and how you receive them. The input-output layer, that's where the changes are. And this allowed the SQL Alchemy team to come up with a very elegant solution. Instead of rewriting the entire SQL Alchemy, they could just write an asynchronous extension for SQL Alchemy, and that asynchronous extension mostly focuses on that input and output. The rest of SQL Alchemy will stay the same. You will still make your queries in mostly the same way. You will work with the results in mostly the same way. The thing that really changes is the communication with the database. And to show that to you, I'm now going to compare synchronous and asynchronous SQL Alchemy with each other. I'm going to do that by giving you a synchronous piece of SQL Alchemy, very simple SQL Alchemy, no advanced knowledge required. I'm going to compare that to the async version, and then we're going to zoom in on the bits that are slightly different. So for those of you who want to know, these are the versions that I used when I made this talk. And if you want to read all the code snippets again, you can find it on my GitHub page. The URL is at the bottom. The slides of this talk are also there, so you can also download the slides from there as well. So let's get to the examples. So in this part, I will first show you a synchronous example, and I will then show you the asynchronous version of it. So when you use SQL Alchemy, you often start by creating an engine. And this is what really takes care of the heavy lifting. It will communicate with the database adapter, which is the application that lies between your application and a database. So what you see here is I pass in the information. I want to use a Postgres database with the Psycho PG2 database adapter. And then there's some information about how we can connect to my database. And this is all local. This is all a test version. So don't worry about the username and password in there. This is all fake, only for this presentation. I'm also turning on echo mode, which means that we get to see the actual SQL that the engine will generate for us. And I'm going to turn on future mode. And this is important because the async extension is written for SQL Alchemy 2.0, which is the new version the developers are working on. And I want to make sure that the queries are the same for the synchronous as for the asynchronous engine. So I've turned on future mode, which basically enables that 2.0 SQL Alchemy query mode. So this is a synchronous engine. So how are we going to make our asynchronous engine? Well, in much of the same way. So as you can see here, there's nothing really different here. The only thing I really did different is I imported the asyncio extension from SQL Alchemy, and I used the create AsyncEngine version instead of the create engine function to create an async engine. But the rest of it is mostly the same. And this is because there's no actual communication with the database happening here yet. So no I/O, so no async required yet. If you really have a sharp eye, you notice that I'm now using the async PG database adapter, which is the asynchronous database adapter for Postgres. But the rest of it mostly takes the same shape. Okay, now let's make an actual query using this engine. So first the synchronous query, and as you can see, I'm doing a really simple hello world in SQL. I'm just doing select hello world, and that is the SQL query that I want to execute. Then I'm going to ask the engine to make a connection to the database. So this is actually doing input and output, and this context manager actually does two things. The with SyncEngine.connect, it will create the connection with the database so we can use it. And then after we leave that with statement, after we leave the context, this context manager manages, it will automatically close the connection to the database for us again as well. So now within the context, I can now use that connection to execute the statement. Then I get the result back. Since I know this is a really simple query, I know it's a scalar, only one value. So I can simply print the scalar of the result, which gets me the hello world. And this is the synchronous example. Now let's get to the asynchronous example. And as I said earlier, the only thing where async truly matters is when we're actually doing input and output. So you'll see that the statement it's exactly the same. I still want to do the same hello world statement. So that part stays the same, no differences there. Then we need to get a connection. And this is where the differences start. Making a connection with the database is input-output. So we need an asynchronous contact manager so we can await the creation of the connection. And then when we leave this context, closing the connection is asynchronous again. So we need to await the closing of the connection. And within this context manager, when we're actually going to use the connection to send a query to the database and get a response back, that's obviously input-output as well. So we're going to await that execution. Once we're done with the connection and the query, once we have the result, from there on out, we don't have to do input-output again. So that part is the same again. So this is to emphasize my point earlier. Creating your query will mostly stay the same. Working with the result will mostly stay the same. It's really about how you execute the statement, how you connect to the database, how you execute your query. That's the part that really needs changing. So now, if you think about it, that looks really simple. But what's the catch? Is there a catch? Well, obviously, there's a catch. You cannot simply rely on implicit input-output. And if you've worked with SQL Alchemy before, you probably know that SQL Alchemy does a lot of implicit input-output. And to demonstrate that, I'm going to create an ORM model for you, so an object relational mapper model. And this is a traveler. So this is a model that you can use to represent someone traveling somewhere. It's a really simple model. It has an ID, a primary key, just to make sure that we can uniquely identify them. We're not really going to bother with this attribute too much, but this is how we can link our travelers to the database and how we can uniquely identify the traveler. We have a created add field, and an important note here is that it has a server default, which I'll get back to later. And it has a name attribute, which is simply a string, maximum 128 characters. And we have an age, so this traveler has an age, which is an integer. So we're only measuring their age in full years. So now, this sounds really easy, but there's a slight catch, and it's this server default. What this means is that we want to keep track of when this traveler was created, but if we don't provide a value ourselves, we ask the database, so truly the database server, to generate that value for us. And if you think about that, that leaves us with kind of a challenge. So if I create my traveler, I give him a name, I give him an age, and I store that traveler in the database, the application doesn't know the created add date because the database has generated that value, it has stored it in the database in the created add column. But if we don't retrieve that value from the database, our application will never know that value. And this is something that you can see when you start working with this traveler. So first look at the synchronous version. I'm going to generate a traveler called Sebastiaan because that's my name. So Sebastiaan, and my age is 35. And then I'm going to store the traveler into the database. So I need a session for that, an ORM session. I'm going to use a session maker, which uses the engine. I'm going to turn expire on commit to false, which means that SQL Alchemy will not mark the ORM instance as expired after we've saved it to the database. Normally it does that because as soon as you save your traveler to the database, you don't know if your traveler in your application is still in sync with the database because another process might have changed the database in the meantime. But we don't want that here because that makes the async case a little bit more difficult to work with. And I'm going to use the normal ORM session class. This is the synchronous ORM session class. And I can now use that session maker to make a session with the database, which is truly input-output. I'm really going to make a session with the database. And then I'm going to start a transaction on that session. This is also input-output. I'm going to establish a transaction with the database. I'm going to add Sebastiaan to my session. And then when we leave this transaction, it will be committed into the database, which means that we will save Sebastiaan, the traveler that we've just created, into the database. And this is important Because if you look at the SQL that gets generated, we pass in the name, we pass in the age, and we ask for the traveler ID back. So in the second line, you can see returning traveler ID. So we get the primary key back, which is important for SQL Alchemy. So I can map the traveler that we have in our application to a specific row in the database, but there's no mention of created at anywhere. So the database will have created the value for us, but we don't get it back into our application. We can actually see that if I now were to print Sebastiaan.createdAt, our application doesn't have this information yet, so it will actually have to fetch it from the database. And this is what SQL Alchemy does. If I now press enter, you'll see that it will actually generate SQL. It will communicate to the database to request the value of createdAt. It will also synchronize the rest of the instance, not really important here, but only now do we know the value of createdAt for this traveler, and only now can we print the createdAt date. So this is really important. CreatedAt is a lazy attribute. It will implicitly fetch the information from the database if we don't have it yet. And in this case, we didn't have it yet, so we had to fetch it. So this is input, output. And this is a problem for the asynchronous case. So with the asynchronous SQL Alchemy, I'm going to create my traveler again. I'm going to make an async session maker. As you can see, I'm passing in the AsyncEngine, and I'm using the async session class. But other than that, it's mostly the same. Then I'm going to create a session with the database. Well, this is input output, so you'll see an async with here. Then I'm going to start a transaction with the database. Again, input output, so this is an async with session.begin. Then I'm adding Sebastiaan to the database. And once we leave the async with session.begin, we will actually execute the transaction and commit it to the database. And that's when we see the SQL being generated again. And again, the asynchronous part, the SQL that's actually generated is pretty much the same as for the synchronous part. We can actually compare them. In both instances, we pass in the name and the age. This is the synchronous version, this is the asynchronous version, and we return the traveler ID. There's slight differences here because we're using a slightly different database adapter, the async PG adapter, but other than that, semantically, it's mostly the same. And this leaves us with a problem, because if I now want to print my createdAt, I need to actually fetch that value from the database, but I cannot simply do this because all my input output needs to be asynchronous, and there's nothing asynchronous about this statement. So SQL Alchemy will actually try to fetch the information from the database, but it will fail. You'll get an exception, and somewhere in the exception message, there's the sentence, was IO attempted in an unexpected place. So for an asynchronous workflow, we cannot simply rely on these lazy attributes implicitly fetching information from the database, because we need IO for that. And in async IO, in Python, every IO needs to be explicit. We have to await the result. We really have to do an asynchronous call to something. So how can we solve this? Well, obviously we can explicitly fetch the information, but there's also a slightly different way, and this is by specifying the eager defaults on the model. So if we look at the eager defaults, I have the same Sebastiaan. I'm going to add Sebastiaan to the database again. You'll notice that the SQL query that gets generated is now slightly different. So here we have pretty much the same SQL query, but there's one additional thing in the returning clause. There's this traveler.createdAt. So when we're creating the traveler, we are already asking the database, well, you're going to create a createdAt value for me and give it back to me. Already give me that information. And this means that after we've created Sebastiaan, SQL Alchemy will already know the createdAt value. Your application will already know it. And now we can simply use that information and we can just print it. We don't have to fetch it from the database again. We've avoided our implicit IO. Something much the same happens in models with relationships. This is the same traveler again. I've removed the created ads because we don't need it now. But what I did add is a relationship to a country model. This traveler now has a destination to travel to. It has a foreign key column, which keeps track of the ID of the destination, so the ID of the country that we're traveling to, and a special SQL Alchemy relationship field, which allows me to very easily access the information of the country a specific traveler is traveling to. And this relationship will also make our life slightly more difficult. And to see that, we're going to create a new traveler, Sebastiaan, and he's now traveling to Norway because Norway is really a beautiful country. And one of the countries I traveled to before COVID. So this is now my traveler. It has a country as a destination. And I can now add Sebastiaan to the database. And now something interesting will happen if I retrieve Sebastiaan again from the database. So I'm going to write a very simple SQL statement. I'm going to select a traveler from the database whose name is equal to Sebastiaan. Obviously, in real life, this is a bit naive. There might be multiple travelers with this name, but in this case, I know there's only one. Now I've fetched Sebastiaan from the database. Oh, sorry, I'm going to fetch Sebastiaan from the database. I'm going to execute this statement. I'll get back Sebastiaan. I know that there's only one true Sebastiaan here, so I can treat the result as a scalar. And now let's look at what the database gave me. It gave me all the information about Sebastiaan, its ID, its name, its age, and even the ID of the country it's traveling to, the destination ID. The primary key of Norway apparently is 1. But what it did not load is the information about the country itself. If you look at destination, it's not loaded. And this gives me a problem if I now try to print the name of the destination, which you might expect to be Norway. We don't have that information yet. We haven't loaded it from the database. So this will fail with the same error as we saw before. So what's the solution here? Well, instead of issuing this query, we can slightly change the query. This is mostly the same. I'm still going to select the traveler whose name is Sebastiaan, but I'm adding in that we want to preload the destination information when I make the query. So when I do this, when I now execute the query, I get Sebastiaan back again. But now instead of not having the country information because of the joint load, because we've preloaded the necessary data, I already know that the country's name is Norway. So the destination field is now loaded, and I can now simply print the name of the destination as well without having to go back to the database because we've already asked that part of the database. So you really have to be more conscious about your input-output when you're doing asynchronous SQL Alchemy. You really have to be aware of what information do I need and when, and then you can preload the information you need. You don't want to do this by default. Maybe you have a very big database with a lot of relationships. You don't always want to load all of them, but you really have to be explicit about the ones that you need right now and the ones which you want to preload. So in this, we're going to skip this slide because I'm running slightly out of time. I'm a bit lengthy today. This brings us to the summary. And the most important point is that if you've ever worked with the synchronous SQL Alchemy or the normal SQL Alchemy, most of what you know directly translates to the asynchronous as well. What you really do need to think careful about are operations that perform input and output. You might want to preload some data. You might want to do it in a slightly different way. You definitely have to await it, and you cannot simply rely on implicit input-output. Everything will really have to be explicit. And this is my main message. Asynchronous SQL Alchemy is not more difficult than synchronous SQL Alchemy, but you do have to be careful about how you perform input and output. And that's it. I hope you enjoyed my talk. I really like that this is online, that I can be there with you, but that also means that I cannot actually really meet you. So don't hesitate to connect with me, get in touch. I like meeting people, so you can find me on LinkedIn. You can connect with me there. You can follow me on Twitter. I occasionally tweet, not a lot. Or you can find me on Python Discord, which is a Python community on Discord. Well, thank you very much. I think we can do a few questions. We have 2.5 minutes left or something. The biggest question is from Tharinda Daja, or do you want to give me questions? What's your name? Prasansa, I think. I don't know how to
Yes.
pronounce it. Yeah.
Yeah. All right. I think I can direct it right to you. Yes.
Okay.
Okay. So let me go with the first. When and when not to use SQL Alchemy is the
So
first
for me,
question. Yeah.
that's a good question. So when would you use it and when don't you use it? Personally, for me, whenever I need to communicate with a database, SQL Alchemy is my first choice. Even if the application is very simple, I will only use the SQL Alchemy core, but it allows me to write my database transactions from within Python. And I really like that. If my application is more difficult, I might use the ORM or use a repository pattern from the book I mentioned earlier. But I basically always use it when I communicate with the database, except when I'm using Django, because Django has its own ORM system.
All right. Thank you. And let's move to another maybe couple of questions.
Mhm.
Yes. Yes, one more. So, can you give a comparison between synchronous and asynchronous SQL Alchemy?
Yeah, so the main difference is that in one, you can rely on implicit input and output, and all your input output is done synchronously. And in the asynchronous SQL Alchemy, you really have to take care about thinking about your input and output. You really have to explicitly await everything you do with the database, so you cannot rely on those on that implicit I/O. But for the rest, it's pretty much the same thing.
All right. And let's go to maybe one more question as time permits. Yep. Does this feature supported by all the SQL Alchemy supports databases? Yeah, I think.
So this is an interesting question. In principle, it should, but it depends on whether or not there is an asynchronous database adapter. So a database adapter is kind of like an application that's between your database and your application. It's an adapter, and only if there's an asynchronous adapter for that implements the right standard, then you can use it with SQL Alchemy. It's in the documentation of SQL Alchemy. So currently the answer is no, but it's not a hard no. It's a maybe. Maybe you can use it with your database, and in the future probably with more databases.
All right. And if there's anyone who wants to direct any questions directly to Sebastiaan, you can also raise your hand, maybe because Sebastiaan is comfortable with that. So if there's anyone, you can use the raise hand option and direct your questions. We will give you a couple of just 1 minute. If there's anyone. Okay, I see one raise of hand. Yes, it's Tihara Jaithuga. Yes, you can direct your question to Sebastiaan.
Hey Sebastian, I was really hoping my question would be picked. It wasn't, so I guess I'll ask it directly. What kind of improvements have you seen when you use asynchronous SQL Alchemy? Now, for long queries, I think it's kind of obvious, like you will gain some performance improvements, but what's the average? Were there any benchmarks, etc., anything that you have done or looked at?
So if you want a really honest answer there, I think that in a lot of applications you don't need to switch to an asynchronous workflow just because of the SQL Alchemy. I think that in most applications, synchronous SQL Alchemy is more than enough. And in fact, your database queries are typically so short that it doesn't really have benefits. There's a great blog post somewhere from one of the SQL Alchemy maintainers, might even be the original author, in which he explains that. So personally, I would only use the asynchronous SQL Alchemy if my entire application is already asynchronous, and I might benefit. I might do some longer queries that where I can then do background tasks or other tasks in the meantime. So I don't really think it's really all that beneficial to go to async just because there's async SQL Alchemy now. It really has to fit in your already asynchronous application. So I'm not aware of any benchmarks, but I doubt that it will really have a significant impact if you already have a very efficient synchronous web application, for instance. Does that answer your question?
Yeah, it does. Thank you.
Thank you so much, Tihara, for that question. And thank you so much, Sebastiaan, for answering our questions from our fellow participants. And with that, we are ending this session. And once again, I extend my heartiest gratitude to Sebastiaan for making this session a success, along with his valuable insights for this session's topic. And also to each and every participant who took part with much interest by being a participant for this session. So we have one more session along with the web track. So hope you all join with us and stay tuned for the next session. And thank you so much, Sebastiaan, and have a nice day.
Yes, thank you as well. Very happy to be here.
See you. Bye-bye.
See ya. Bye.